This lesson is going to go over the distributive property using expressions. Your learning target is down here at the bottom. It says that I can combine like terms using the distributive properties. So our last lesson focused on specifically just combining like terms. And we're going to still use that today, but we are going to add in the distributive property. This is something you guys have done before in the past. We're just going to combine these two ideas together. You guys might hear my son in the background from time to time. I am recording this at home, so if you hear anything, that's just Cooper. The distributive property, just as a review, it states that multiplying a number by a group of numbers added together is the same as if you did the multiplication separately. So let's go ahead and take a look down here at this example. And right here it is saying 2 times 3 plus 4 in parentheses. 2 times 3 plus 4 in parentheses. So I'm going to go ahead. I'm going to write this a little larger right here. Okay. So in other words, we have talked about this before as well, that there is a tiny little multiplication sign that is in between the 2 and this group of numbers. So this is saying 2 times this group of numbers. So what we want to do is we want to distribute the 2 to the 3 and to the 4. So when you think about the word distributive and it has the root word distribute means to hand out or to give out. So that's what we're going to do with the number 2. So I'm going to go ahead and distribute this 2 to the 3. And that is why they get 2 times 3 over here. And I'm going to distribute this 2 to the 4. And that is how they get the 2 times 4 over here. And we're still adding these amounts together because inside the parentheses you are adding. So now we have 2 times 3 plus 2 times 4. 2 times 3 is 6. 2 times 4 is 8. And here we are again at combining like terms because 6 and 8 are both constants. So when you add those together, you get 14. All this is showing you up here in the algebra example. Algebra is just when you start to include variables or letters that represent numbers. So they're just showing you if you took A times a group of numbers B plus C, you could distribute the A to get A times B, distribute the A to the C to get A times C, and you still are going to add those two amounts together, so AB plus AC. So here's a basic example of the distributive property. We have 6 times x plus 7. Now x plus 7 is in parentheses. They are grouped together. So what that means is we're going to take the 6 and distribute it into this group. So 6 times x right here would give you 6x. 6 times 7, this is a positive 7. 6 times 7 would give you 42. Now, when we get down here to the 6x plus 42, we don't have any terms that we can combine because we don't have any terms that are the same. They are different. 6x is going to stay 6x. 42 is going to stay 42 because this is a constant and this is a coefficient attached to a variable, just to review our terms a little bit. So 6x stays its term, 42 stays its term, and your simplified expression is 6x plus 42. Now, this is a slightly more complicated example, but really the only difference here is that we now have a negative out in front of the number that we're going to be distributing. So this expression reads as negative 9 times 8 plus 3b. The 8 plus 3b are in parentheses, so that says it is a group of terms that are going to be multiplied by negative 9. So as I've been telling you guys, we have to always be looking at signs. We have to continue to practice to just always make sure we're looking at our negatives and positives. So here, when we distribute negative 9 to 8, we're really multiplying negative 9 times 8. So what that's going to do is it's going to cause us to have a product of negative 72. So it just changed the positive 8 to a negative 72. When I distribute the negative 9 to 3b, the same thing's going to happen. You have a negative times a positive. So negative 9 times 3b will give you negative 27b. Now, this right here, negative 72 plus a negative 27b is correct. But we're trying to simplify expressions, simplify going to the most compact version of the expression that we can. So what we're going to do is almost think backwards to what I've been telling you since the beginning of the year. And when you see that you're adding a negative right here, we're going to go ahead and just call that subtraction. Okay, so now we're going to go from a negative 72 plus a negative 27b and call it negative 72 minus 27b. But remember, we could go back and forth. We could also change this subtraction problem back into an addition of the opposite. And last but not least, the reason I rewrote it down here at the bottom, what we talked about in class, is that it is math etiquette, or it is just good manners in math to write the variable before the constant. So all I did was take negative 27b and write it first, and then I put minus 72. For this example, I would like you to go ahead and pause the video, try it on your own, then hit play and see if your answer matches my work. Okay, let's go ahead and try this. So we have an expression in front of us. Remember, expression, there is no equal sign. Our expression reads 3 times the quantity 4m plus 7. This is in a group because it has parentheses. So what that means is we are going to distribute this 3 to the group 4m plus 7. I always draw these arrows here when I'm distributing, and I'll explain why in a second. But we're going to distribute the 3 to the 4m. Positive 3 times a positive 4 would give me 12m. Then I'm going to distribute this 3 to the 7. Positive 3 times a positive 7 will give me a positive 21. Now, the reason I draw these arrows is a lot of the time, students will distribute this 3 to the first term right here, and then forget to distribute it to the second or third or however many terms you might have in the parentheses. So drawing these arrows reminds you, okay, I have to distribute this 3 to the 4m. I have to distribute this 3 to the 7. It's forcing you to think about every term in the parentheses and making sure you multiply 3 by every term. So your answer here would be 12m plus 21. We cannot combine like terms because 21 is a constant and 12m is a coefficient with a variable. So those guys stay separate. Go ahead and do the same for this problem. Try it on your own, pause the video, and then unpause so we can go over it together. Okay, so this expression reads 10 times the quantity 7x plus 1 plus 2 times the quantity x plus 5. So it looks a little more complicated than our last example, but it's really not too bad. All you see is that you have a 10 times this quantity here, and you have a 2 times this quantity here. So we need to go ahead and distribute. So again, let's draw our arrows. 10 times 7x, positive 10 times positive 7. It's going to give me 70x. 10 times 1 is going to give me 10. Now let's come over here and distribute our 2. 2 times x, positive 2 times positive x, gives me 2x. 2 times a positive 5 gives me positive 10. Okay, so now my parentheses are gone. I've distributed my 10 and my 2. So now I need to look and see if I can combine like terms. Well, let's think about this. We have a 70x here, so we have an x with its coefficient here. We also have an x with a coefficient of 2 here. These are like terms, so let's go ahead and combine them. 70x plus 2x is 72x. We also have a constant of 10, positive 10. Another constant of 10, positive 10. And I really almost should box the sign in with it so that you guys know that these are positive. And 10 plus 10 is 20. So our final simplified expression would be 72x plus 20. This expression is exactly the same as this expression up here. We just condensed it and simplified to combine like terms.